Hi, this is Austin Laff. This is my attempt at a vlog for my Chemistry 151 weekly reflections. So let's jump right into it. So let's start with what we actually did in class. The unit section is called Describing Stuff. And this week we were mainly focused on the topic of conductivity and naming different types of compounds. Now, for our first activity, we compared the conductivity of water, salt, and sugar. Um, And in so doing, we also were discussing different observations we made about them, such as the conductivity in a pure state, the conductivity in an aqueous state. Which right there, I found something pretty we found something pretty interesting was that sugar is non-conductive, and when it's in an aqueous state, also non-conductive. However, salt is non-conductive in its pure state, in its solid form, but if you add it to water, it all of a sudden becomes an electrolyte. I thought that was pretty cool. And we also took a look at the fundamental particles. We just broke them down by their different elements and molecules, and we also looked at the connectivity. We And finally we took a look at the types of elements in the compounds, whether they were two nonmetals or a metal and a nonmetal, and then finally we looked at the scientific name for each type of compound, whether it was molecular or ionic. Um, Now next, we were basically just naming different types of compounds. So we went over a few examples of ionic compounds, um, which is yet again where I found something pretty interesting. Now, in my Chemistry 130 class, we were taught the crossover method, which Professor Root, rightly so, has kind of a problem with. Um, I think what I took out of this class mainly was that the crossover method can work, but it's more important to understand kind of the reasoning behind it. So we'll take the example of lithium phosphide. So lithium, each lithium atom has one positive charged electron. Phosphorus has three positively charged um, electrons. So what we need to do is we need to even it out. So that's why we need three lithiums for every phosphorus in order to make lithium phosphide. Uh, that kind of that kind of gave me a better understanding of how this whole naming thing works. And we also took a look at examples of molecular uh, non electrolyte compounds, such as carbon tetrabromide, iodine monochloride, dinitrogen oxide, xenon tetroxide, um, and that was interesting as well. Um, it's cool that you could basically infer the chemical formula just by looking at the name of the chemical of the compound rather. And we also took a look at ionic electrolyte compounds. I already mentioned that. And then we took a look at polyatomic ions. This was also interesting because we basically took some different compounds and named them, such as ammonium hydroxide, potassium sulfate, uh, and a couple other examples of those. And then finally, we ended off by naming the different types of acidic compounds. Um, what was interesting to me was that I already mentioned the that in Chem 130, I the crossover method was what I was taught. But well, and I mean I think the main takeaway here is that the naming is very very important. It describes what a certain what's in certain chemicals and compounds. Just by the name we could tell so much. We could tell whether it's ionic, molecular, polyatomic, or acidic, and we could also tell. We could even basically break down the actual chemical formula, the empirical formula. So I thought that was all really interesting, and I think it's very important to know this and get this down. So that's pretty much what I learned this week. That's kind of my weekly reflection. If you have any questions, let me know. Have a great night. Bye.